Okay, welcome students. So the aim of today's experiment is to find the velocity of ultrasonic waves in water. So this is the name of today's experiment. Let me write down the apparatus required. Okay, apparatus required is actually we need ultrasonic interferometer, complete kit, and just water. Nothing else. We need this thing only. So then what is the formula used? Formula used is very simple. We know that velocity of a wave is given by so velocity of the wave is given by velocity is equal to product of frequency and wavelength. I guess everybody amongst you knows this, and rather I will be using this formula f lambda. I am using symbol f, which is equivalent to nu. It is the frequency of the wave. Okay, here we also know in case of let us say this is equation number 1, let small d is equal to distance between two consecutive antinodes or nodes. Then we can write that this you have studied in your school physics, that distance between two consecutive antinodes or nodes is given by d is equal to lambda by 2, or lambda is equal to 2d. So if we put this value in 1, then we get velocity is equal to 2df. So given here is given f is equal to frequency of ultrasonic waves. It will be 2 megahertz. This is given to us. So we can write therefore f is equal to 2 megahertz, which is further equal to 2 into 10 raised to power 6 hertz. So this is the formula that we will be using. The frequency of the ultrasonic waves in our experimental kit that we will perform in the experiment will be this one. So this is given to us. So let me move to the next page. Okay, in the next page we have now circuit diagram. So in case of circuit diagram, we will have this ultrasonic interferometer. It will have one on off switch, and it will have some micro ammeter here. This is micro ammeter. Here it will be its output cable, and this output cable will be attached to the base of a cylinder, over which we will place liquid cell. There will be knob. These are obviously screws. There will be screw gauze here. This liquid cell will be filled with water, and this is screw gauze, and this screw gauze is attached to the piston, and this piston can move up or it can move down. This is connecting lead. This is ultrasonic interferometer. And we can rotate this screw either clockwise or anti-clockwise. So when we move this screw clockwise, it will go down. When we will move this screw anti-clockwise, it will go up. Here we have in the base we have a pin. This pin has got a supply from this cable. Around it we have a spring. It's like this, and there we have a disc. This is a disc. This is spring. There is a pin, and this produces electro. This produces AC voltage of frequency 2 into 10 raised to power 6 hertz, that is 2 megahertz. So this is the circuit diagram. Now let me discuss about brief theory. So we know that ultrasonic waves are longitudinal waves just like sound, but their frequency is more than audible range. That is 20 kilohertz. So whenever sound waves have frequency more than 20 kilohertz, these sound waves are called ultrasonic waves. So ultrasonic waves are nothing more than sound waves, but we cannot hear them because their frequency is more than what human ear can recognize. So these waves are to be produced here. So what we do in this ultrasonic interferometer, we produce uh, we produce electromagnetic waves, or sorry, not electromagnetic waves, we produce electric waves or AC voltage of frequency 2 megahertz. This is the job of this ultrasonic interferometer. It produces these waves. Now you can see there is a spring. This is a spring. It's like this, and in this spring we have placed a pin, and when we give supply to this pin of the order of 2 megahertz, then because of Faraday's law, this spring starts vibrating. It starts vibrating, and over this spring we have placed a disc. So if spring vibrates, then disc also vibrates, and this disc is putting pressure on the liquid bottom. So there is a cell, and this cell is touching from the bottom to this disc. So this cell is filled, this cell means cylinder, it is filled with okay, of course, water. So when this disc will vibrate like up down, then it will produce sound waves, or rather ultrasonic waves, because of the vibration of water will take place. So as a result, ultrasonic waves will move upward. The frequency of these ultrasonic waves will be exactly equal to the frequency of vibration of the disk. Since the disk is vibrating with the frequency 2 megahertz, so therefore ultrasonic waves will be produced. These will also have frequency 2 megahertz. But we have placed a piston in the cylinder. So when these waves strike the piston, these waves get reflected back, and after reflection these start coming backward. So there are two kind of waves, ultrasonic waves. Progressive waves, this is called incident wave, YI stands for incident wave. This is a reflected wave, this is YR. So incident wave is YI, its direction is from disk to piston. Wait for a while. So its direction is from disk to piston, and YR is reflected wave, and its direction is from piston to disk. So let me go to new page. Therefore in the water we have two waves, progressive waves. This is one progressive wave, this is another progressive wave, and when these two progressive waves will mix with each other, we will, this is a progressive wave, this is also a progressive wave. Both waves are identical and they have identical frequency, wavelength, amplitude, but their direction is different. And when these waves mix with each other, stationary waves like this will be formed. You have already studied stationary waves in your lower class. Sorry for poor drawing. Let me rather draw it appropriately. Like this. These points are called nodes. And between two nodes there is half of the wavelength. And these points are called antinodes. Between them, this is also lambda by 2. Similarly, all these distances are lambda by 2. Between two consecutive nodes or between two consecutive antinodes, the separation is always equal to half of the wavelength. Now, what is happening? You can see at node, displacement is 0 or minimum. It means water molecules are at minimum separation. These have moved close to each other. Water molecules have moved close to each other, and at therefore the density of water will be more than the actual value. Density of water at node is therefore maximum, and at antinode water molecules are farthest, that you can see in the figure. This at antinode water molecules have gone away, at node the water molecules are very close to each other, so therefore density of water will be now minimum here. Now if I show you the diagram, in this diagram we have a microammeter. It tells the current required to produce these alternating AC voltage. Now there is a pressure on this disc, and this disc has a pressure, and this piston is moving upward and downward. So we can move this piston upward or downward by using this screw gauge. Now you can see when this piston is moving, so this piston can sometimes be in contact with the node, and this piston can sometimes be in contact with antinode. Let me show it separately. Wait for a while. Okay, suppose this is the piston here. Okay students, sorry for inconvenience. I will continue my discussion from now. Okay, suppose the piston is here, and this is the disc, bottom disc, and we are having this kind of waves. Please carefully understand this part because this is the most important part. Okay, now this is the piston, this is the disc, this is the piston. You can see piston is right now at antinode. If I move the piston upward, soon piston will reach here. What is this? This is node. If I further move the piston upward, soon the piston will reach here. What is this? This is antinode. If I further move the piston upward, it will reach node, then it will reach antinode, then it will reach node, then it will reach antinode, and so on. Now look what I have written here. Please see this. Water molecules are at minimum separation at the node. So at node, please see at node the pressure is because water molecules are closer, the pressure and the density of the water, it will be maximum. So that will produce, that will make the vibration of the disc difficult. Please recognize this because the water is putting maximum pressure. So at every node, this disc at node, disc will need more energy to vibrate. And if the piston is at antinode, just like at this point, you can see this, there the density at antinode, the density or pressure is minimum. Therefore, disk needs less energy at antinode. Disk needs less energy or minimum energy to vibrate. So it means disk needs minimum energy to vibrate. It means the current passing through the circuit at the nodes will be maximum, and current passing through the antinodes will be minimum. You have to understand this thing. So current will be maximum and current will be minimum at nodes and antinodes respectively. So it means this is the 0 on microammeter, and this is the, let us say, I think it was up to 100 micrometer. So the last is 100 micrometer. So there are gradings here like this. So if I move the piston upward, since node and antinode are coming alternatively, so whenever our piston is moving toward the node, the current of the needle, the current shown by the needle, it will be increasing while moving toward node, and this needle will move to the left, the current will be decreasing while moving toward antinode. So we can therefore find at which place current is maximum. Whenever current is maximum in the circuit, please remember, therefore we have made a formula that when current is maximum in the circuit, then piston position is node and vice versa. So this is important thing. So if this node current is maximum, let us say position of the piston is x1. This is the next consecutive node. Please remember, we either take reading of nodes only or either take reading of antinodes only. So I will make a choice. I will take the reading of nodes only. So let us say these are the consecutive nodes. Suppose the position of the piston here is x1, this position is x2, this position is x3. Corresponding to these three positions, current has shown me maximum values. So, and I will be noting these positions from screw gauge. So I will show this video to you also. So this screw gauge will help us to identify the readings of x1, x2. Let us say there is one more loop, let us say, and this position is, let us say, x4. So if I can note this distance, let us say this is distance is d3. Suppose the distance between these two nodes is d2 and the distance between these two nodes is d1. So please remember, I will be showing you a video. Kindly forgive me while recording that video. Whenever the current was maximum, instead of speaking, let me change the color. Please remember, in the next video, after this, I wrongly spoke micrometer instead of micro ampere while noticing current readings, current maxima. Please make a correction. So ignore these. So let me add new page to this. I will upload this lecture on YouTube also. So therefore D1 is equal to second node position minus first node position. D2 is equal to third node position minus second node position, and D3 is equal to fourth node position minus third node position. If I can take these readings from screw gauge, then I can find average value of d. That will be d1 plus d2 plus d3 upon 3. That is average distance between two consecutive nodes. So this can be easily found. Therefore, I can find the velocity that was equal to 2df. So d will be found from here, and f is known to us. So we can easily find the velocity of the ultrasonic waves in water. Please remember, actual velocity of ultrasonic waves in water at room temperature is roughly 1500 meter per second. So we will find the percentage error with regards to this. Now for noting the readings, we need to explore screw gauge. Let me add a new page. So in case of screw gauge, I will show you, this will be reference line, and here we will have 0, this will be 1, 2, 3, 4 and 5. This will be 5. This is reference line. This is called main scale, and this unit is in millimeter. This will be obviously then 6, 7, 8 and so on. Then there will be a circular scale here. And main scale is actually long, it will go inside. Only this portion will be visible, whichever is not covered by the circle. So there will be markings over this. So there can be, let us say, this is, let us say 0, this is 1, this is 2, let us say this is 3, this is 4, this is 5, 6, 7, 8, 9 and 10. Similarly here we will have markings like this. So this will be screw. This is circular scale. Circular scale. Now this is in millimeters. So on one side we are having integers, integer readings. On other side we will have half integer readings. There are, so this is reference line. On one side of reference line we are having integer readings. On the other side we will have half integer readings. Like this. So this is actually 0.5, this is 1.5, this is 2.5, this is 3.5. Similarly this is 0, this is actually 1, this is actually 2, this is actually 3. While taking the reading of the main scale reading, we have to take care of both. Now in the main scale reading you can see, for this particular example you can see 0.51, 1.52, 2.53, 3.54, 4.55 and 5.5. Let me make it slightly clear. So you can see from integer side, from this side maximum reading visible is 5 mm, and from this side maximum reading visible is 5.5 mm. So for this particular example main scale reading, it is the maximum reading visible on the maximum reading visible on main scale, on main scale. So that is actually 5.5 mm, and circular scale reading, it is equal to number that is coinciding into least count. It is number of the division that is coinciding into least count. So if you can see this reference line, I will change the number color. This reference line, you can see it is in contact with, this is 0, 1, 2 and 3. So this is third circular scale reading. So here n is equal to actually 3. So it will be 3, and least count is 1 by 100 mm for this equipment. You can verify this very easily when you visit our laboratory. So it will be 0.03 mm. So total reading is always the sum of both. Total reading of screw gauge is actually sum of main scale reading and circular scale reading. This will be 5.5 plus 0.03, that will be 5.53 millimeter. This is how we will take readings. So I will stop here. Let us now perform the experiment, and I will show you the video of the experiment. So I will stop
Excuse
here
me,
for
sir.
this part. Yes, please.
Sir,
Hello students, welcome to the experimental setup of this experiment to find the velocity of ultrasonic waves in water or any other liquid. So this is the power supply, and this is the electro ultrasonic interferometer setup. So you can see here there is a on off switch here, and then you have a micro ammeter. Then these two are the zero adjustments, these two. This is a zero adjustment and this is a range adjustment. This is the supply, and I will connect this lead. This lead will be connected from the other side to this cylinder, and I can show you that if I open this knob, then you can see at the bottom of the cylinder there is a metallic pin. This metallic pin will get the supply from this lead. So let me just connect this lead with the base of this cylinder from one side. So the other side of the lead will be connected to this terminal, this port. So the connections should not be loose, these must be tight. Now this connection is okay. Now you can see there is a pin. If I show you this cylinder, it has a bottom, there is a pin. There is a pin here, and at the bottom of this cylinder there is a hole. So if I put this here, then this pin will enter into the hole, and it will be, actually there will be a spring around this pin in the bottom. I cannot show you that, but it is there, and on the spring there is a disc, and that disc will be in the contact of this water. Now let me show you about this cylinder from inside. If I show you this cylinder, if I open it, and now I have opened this cylinder, you can see here this is a piston, and you can see here I have filled this cylinder with water. I guess you can see this water. So this this piston which I am touching, this is the bottom of the piston. So the other end of the piston is passing through this rod and it is attached to this screw gauze. Of course it's I will show you it otherwise. Of course its least count is quite less, or it is more accurate. Now you can see here there is a this one there is a problem of autofocusing. Yes, this one is the main scale and this is the circular scale. Now you can see the 45 written on this is on the circular scale, and if you are seeing this 0, 1, 2 horizontally, this is the main scale. You can see there are actually markings below also. These are engraved markings, and similarly you can see this is circular scale. You can see there are 50 divisions on the circular scale, and if I open this main scale, it can open up to 25 millimeter. I will not show all. Now you can see 5 mm has been opened on the main scale. Okay, so this horizontal line is this horizontal line, if you can see here, there is a horizontal line. This is the reference line. I have to match, for example, now 15 of circular scale is matching with the reference line, and now 10 of the circular scale is matching with the reference line. If I rotate the screw in this direction, then the circular scale reading is increasing. In this direction, the circular scale reading is decreasing. So let me now put this piston into this cylinder which is filled with water. So this cylinder is now being, you will gently release it. Okay, after gently releasing it, so I am going to tighten this knob so that it becomes tight. So now this is now tight. Now I will, because it is still loose, so I will now tighten up this screw. So I have tightened up both of these screws. Now there is a time to take the readings. When I rotate this screw clockwise, then this rod which is attached to the piston, this piston, bottom of the piston is somewhere here in the cylinder. So if I rotate this screw clockwise, this piston will go down, and if I rotate this screw anti-clockwise, this piston will move up in the water. So let me move it slightly downward so that there is a provision not to move it anywhere. If I press, I have already started the main lead. Now I will switch it on from here. So you can see there is some reading given by this micro ammeter. So if you can see here, this reading is somewhere between 50 to 60 microamperes. We will usually keep this range. 50 to 60 microampere is good actually for us. Now I am going to rotate this screw. So when I will rotate this screw like this, I am moving it anti-clockwise so that it moves up. Then you will see this needle will show deflection. Let me show that. I am now moving it upward and the needle is going toward the right side. Now it is going toward left. Again it is going toward right. Now it is going toward left. Again it is going toward right side. So this is how you can verify that stationary waves have been formed in the water and there is a node and antinode formation. Wherever the current will be maximum, it will be node, and wherever the current will be minimum, it will be antinode. So this reading, if this reading I am moving it, again I will move it. So this reading is going maximum up to 78 or 79 micrometer, I guess. Let me refocus the camera. Okay, so it is going up to 78 micrometer and it is coming up to 50 micrometer. So this is good. So please remember 78 is my global maxima and 50 is my global minima. In between there is let us say needle is changing its direction from 63 micrometer and 59 micrometer. Please remember 63 is a local maximum and 59 is a local minimum. Before starting the experiment, we have to identify the global maximum and global minimum. Okay, so now we have identified that global maximum is 78 and global minimum is roughly around 50 micrometer. So we will take the readings. We will take the readings only when the needle will touch these two values. So we will not be confused from the local maximum and local minimum. If I rotate this screw, you can see the needle is moving away and then it returns back. Now this is a limitation of the camera. I cannot simultaneously focus this camera on screw as well as the needle. So this I have kept unfocused. This I have screw I have kept as focused. So you can just see the needle moving. I have already told you that the local maxima is somewhere around 78 and the local minima is somewhere around 50. So if I move it, now you can see the readings are decreasing and the screw is moving clockwise. It means piston is moving down. So I would not take the readings by moving the screw down. Now this 0 is in contact with the reference line. So this is our 0 of the circular scale and this is the reference line of the main scale. This is 0, 1, 2, 3, 4, 5 and on this side I will not show you, I will show it later. On the this is the reference line. To the left of the reference side we have integers divisions. To the right of this reference line on the main scale we have half integer. Actually 0 is here, 0.5 will be on this side, 1 will be on this side, 1.5 will be on this side, 2 will be on this side, 2.5 will be on this side. So I will show you later on. So let me take the readings now. So I will now move this screw upward, that is anti-clockwise, so that the readings of the screw will start increasing. Now you can see this has reached near about 80 and it has now turned back. It is now just changing its path. So it is a global maximum and the needle is at its maximum position. If you see the reading of the screw gauge, then the screw gauge is showing me some reading and that reading I would call it to be X1. So this X1 reading, for this X1 reading, if I take a closer look up at the screw gauge, so you can see the main scale reading is 0, 0.1, 5, 2, 1, 1.5, 2, 2.5, 3, 3.5 and 4. So main scale reading is 4 and the circular scale reading is more than 10 and less than 11. So we will always take the smallest. If the reference line is between two circular scale divisions, then you will always take the smallest of the two. Now you can see this reference line is between the 10th and 11th division of the circular scale. This is the reference line. This is the reference line, and it is between 10th and 11th. So we will always take 10th. And on this side you can see here that 0 is visible, 1 is visible, 2 is visible, 3 is visible, 4 is visible. And on this side, yes, you can see that 0.5, 1.5, 2.5 and 3.5 is visible, 4.5 is not visible. So the maximum reading that is visible on the main scale reading is 4.5 mm. So on the copy I will write x1 is equal to main scale reading plus circular scale reading. It will be sum of both. Now the main scale reading is actually, it was between the maximum reading which was visible, that was 4 mm. And the circular scale reading is actually the number of division multiplied by the least count. The least count of this screw gauge is actually 1 by 100 mm. So rather than calling it micrometer, I would call it as screw gauge, because least count is still 1 by 100 mm. It will be 0.01 mm. So therefore my reading of x1, which is the first node that I have noticed, it will be 4 plus 10 was the coinciding reading into 1 by 100. It will become 4.10 mm. So this is the reading of the first node. Let me now move it anti-clockwise, and you can see this needle is coming. You can see this needle is moving to the left. Let me check the reading of the screw. You can see now yes, you can see now initially 4 was visible. Now this is 0, 1, 2, 3, 4. Now 4 is clearly visible. Earlier it was just visible. You can see here this is 0.5, 1.5, 2.5, 3.5. So 4.5 is still not visible, and the reading on the circular scale is now between 46 and 47. So we will take it to be 46. So my value of second node is x2, which will be equal to 4 plus 46 into least count, that is 1 by 100. It will be simply equal to 4.46 millimeter. So this is at maximum and this is at 46. Now I will rotate. I will try to show you both of the things in a single shot. So you can see here the needle is also and the screw is also. I will move it further anti-clockwise. So the needle is moving to the left and I am moving the screw upward. So this is a local minimum. We will ignore this local minimum and local maximum. Now the needle is approaching toward global maximum. So I would move it here. So you can see this is okay. Now it has changed its direction. The needle has just started moving down. Let me take the reading of the screw. Okay, now you can see it clearly. This screw is now, if you watch it, this is 0.5, 1.5, 2.5, 3.5, 4.5 is now visible. On this side you can see 0, 1, 2, 3 and 4. 5 is not visible, but 4.5 is visible. So on this side the visible reading is 4.5. On this side the visible reading is 4. So since 4.5 is bigger than the 4, so therefore screw gauge reading, main scale reading is now 4.5 mm. And on the circular scale you can see this is 30, this is 31, this is 32, this is 33, and you can see reference line is in contact with 34. So I will take the main scale reading to be 4.5 and circular scale reading to be 34. So my next node is at x3, which will be equal to 4.5 plus 34 into least count, that is 1 by 100. That will become equal to 4.84 millimeter. So now we are at the global maximum. The circular scale reading is 4.84. So I will now not shift focus because you have seen so many readings combinedly. Now I will move the screw upward and I will now focus the needle. Okay. It is moving to the left. You can see it is very well focused now. Video is very well focused. So it is moving to the left and antinode has passed. This is to be ignored. This is local maximum. This is local minimum. We will ignore this. Now it is moving toward global maximum, which was near about 80. So, okay, you can see needle has changed its direction again toward the left. So it is a global maximum. Now we will take the reading. You can see clearly here. If you are able to see this, this is 4.5. I guess you are mature enough. There is no need of me counting every division now. So this is 4.5 and this is 5. From this side 4.5 mm is visible. From this side 5 mm is visible. So bigger of these two is 5. So I will take the reading of main scale to be 5 mm. And if you see this reading, now this main scale, this is 20, this is 21, this is 22, this is 23, this is 24. So the reference line on the main scale is between 23 and 24. So I will take the circular scale division to be 23. So my next node, which is at x4, x4 is actually, this is 5 mm plus it was 23 into least count, and this is equal to 5.23 millimeter. Okay, now we want to find the distance between the consecutive nodes. So now we have, I will make a summary here. Now we have x1 equal to 4.10 mm, x2 equal to 4.46 mm, x3 is equal to 4.84 mm, and x4 equal to 5.23 mm. Now d1 is the distance between two consecutive nodes. It will be equal to x2 minus x1. It will be equal to 4.46 minus 4.10. This will be equal to 0.36 mm. Next, d2, node distance between second node and third node. It will be 4.84 minus 4.46. So this distance will be equal to 0.3 and 8 mm. And d3, it is the distance between third node and fourth node. It will be x4 minus x3. It will be x4 minus x3. It will be equal to 5.23 This is 5.23 minus 4.84. This is actually 3, this is 2. So it will be 0.39 mm. Now we have found three values. So the average value of D, it is given by D1 plus D2 plus D3 upon 3, sorry, because I have made 3 observation. It was 0.36, 38 and 39. It was 0.36 plus 0.38 plus 0.39 upon 3, that will be equal to, it will be equal to 1.13 upon 3, that will be equal to 0.3 7 mm. So you can round off, you can use rounding off. So average value of D will be equal to 0.38 mm. So we can now find the value of the speed of ultrasonic waves in water by using the formula that I will now describe on my graphic tablet. Thank you. Okay, welcome students. Now we have made the calculations. We have found that we observed that average value of D found by us was 0.38 mm. So it will become 0.38 into 10 raised to power minus 3 meter. Therefore, V is equal to velocity of ultrasonic waves in water. It will be equal to 2 df. That will be equal to 2. D is actually 0.38 into 10 raised to power minus 3 meter into F is 2 into 10 raised to power 6 hertz. So this will become, let me find this answer on my calculator. Okay, this becomes 1520 meter per second. This is the observed value. So actual value is 1500 meter per second. So percentage error it is actual minus observed upon actual into 100, that will be 1520 minus 1500 upon 1500 into 100, that will be 20 by 100, 20 by 1500 into 100, that this will go, so it will be 20 upon 15, that will be equal to 1.33%. So our result is very well within the acceptable limits. So I hope you have enjoyed today's experiment. So I will stop here now. Thank you. Thanks a lot.